Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. Today we're discussing the paper Creating Healthy Friction, Determining Stakeholder Requirements of Job Recommendation Explanations. A lot of good things to unpack here. First and foremost, the interesting application of recommender systems in job hunting. And as we get into in the discussion, it's not just the job seeker who's a relevant participant here. Our guest today, Roan, and his co-authors use a graph-based learning technique. But more important than that, they focus on giving explanations for why the particular recommendations were given to each user. The rather intuitive idea here is that if you explain why a particular recommendation was given, that should be advantageous. Either the user might understand the context and appreciate it more, or maybe they'll find a job faster, at least one that they seem qualified for and interested in. But the presence of those explanations has a surprising outcome. I won't spoil the punchline. We'll get into that during the interview, which should start right about now.
My name in Dutch is Roan Schellingerhout, and I am from Maastricht University. I'm a fourth-year PhD student there. And in English, you can say my name is Roan. It's different in Dutch and English.
And can you share a few details on what you're studying there?
Yeah, so I'm currently doing a PhD. The exact topic is explainable multi-stakeholder recommender systems. And in our case, we're looking specifically at recruitment, so HR.
Could you zoom in on multi-stakeholder recommendation systems? That's not a prefix I encounter too often.
Yeah. So it's basically just a recommender system in which there are multiple stakeholders that have to use the system. So in the case of recruitment, that's job seekers, but also companies, people working in HR at companies, and recruiters who can either work at a company or at a third party. So in general, a multi-stakeholder recommender system is just a recommender system where multiple stakeholder needs need to be balanced.
And I invited you to come on to discuss the paper Creating Healthy Friction, Determining Stakeholder Requirements of Job Recommendation Explanations, which obviously we're going to have a lot of follow-ups about, but I thought before we jump right in, I've noticed you've got also a lot of other publications in and around the recommender system and personalization space. Could you talk about your sort of broad research interests? What all are you taking a look at?
Yeah, so it started initially during my bachelor's thesis. There I started working on a paper that looked into the YouTube recommender system's treatment of conspiracy content, basically how the recommender system dealt with content that wasn't technically allowed to be on the platform in some cases. There I was kind of trying to open up the black box, which sparked my interest for explainability. And then during my master's thesis, I worked with Randstad. It's a recruitment company. I think in the United States, it's called Monster.com. I think that's their sister company in the US. There I worked on explainable career path prediction. So given someone's career up until now, try to predict what their next job will be in an explainable manner. Yeah, I had interest in both explainability and recommender systems, and then while focusing on recruitment. So then when I started my PhD at Maastricht University, I tried to combine all of those. So we look a lot into how we can meet explainability needs, mainly of lay users. So basically people who don't have a lot of technical expertise, how we can make sure that they are able to understand and work with explanations for job recommendations.
Well, if they have no technical expertise, you probably don't want to give them a SHAP value. What do you give them?
So exactly, indeed. Working with SHAP and Lime and whatever, that's perfectly fine if you're dealing with data scientists, of course, but not with your average Joe. In the first paper that we worked on during my PhD, we kind of asked that exact question, what do we give them? So in that case, we showed them textual explanation, so just a written text, or bar charts, which are already going a bit more in the direction of Lime and SHAP, of course. Or one that we showed was a graph-based explanation. So it's basically a network of nodes and edges that are connected. And then in there, you can see kind of a path going from, because you had this experience that's related to this subfield, which is relevant for this job. So those were the kinds of explanations that we showed. And we found that for most lay users, textual explanations are the easiest to deal with. Just a running text gives you an overview of why a job is fit for you.
Well, I'd love to go through the sort of user experience of each of those. Maybe we can start with just textual explanations. I'm imagining myself a job seeker on a website. Typically, I've done some search and then I've got a bunch of listings or matches, I guess you'd call them. where does the textual explanation appear for me, and what might it tell me?
The exact location, that would be up to the provider, of course. But what we focused on was that when you already have a bit of a short list of potential jobs that you're interested on, just based on the text and maybe the description and whatever, then when you click on them, it also gives the textual explanation. And there, yeah, it's basically what is supposed to be in there, at least is what a recruiter might also tell you. So it's like, oh, you have this type of education, which is suitable. You have this work experience, which fits this job because of X, Y, and Z reason. And we think you'll do well in this environment. Just general arguments that you would expect from a recruiter as well.
And how do you end up generating the explanations?
What we are focusing on mainly is using knowledge graphs and then feeding those knowledge graphs into large language models to get easy to understand explanations. Because what we found out was that using those graph-based explanations can be very difficult because they're, again, pretty technical. There's a lot of things going on at the same time. So if we then feed the graph explanation basically into an LLM, like a JSON version of the graph, and then tell the LLM, based on this, provide a easy to understand explanation, the output of the LLM is then what is shown to the user as well.
You'd mentioned bar charts as well. What's the user experience like in that case?
There we basically wanted to see bar charts are kind of the industry standard when it comes to explanations, or the most common, I guess, when it comes to explanations. So we wanted to see, if you present what we're used to a lay user, to an average Joe, how do they actually respond? And what we found is that lay users really do not like bar charts. They said, I don't understand what I'm looking at. I don't know what I'm supposed to be doing with this. They basically looked at it, were confused, and then moved on to the textual or the graph-based explanation. So we found that there's very little use generally, other than maybe supporting texts a little bit. So what we did was, at one point we had textual explanations, and then in there we would highlight certain terms that corresponded to features in the system. And then next the text, it would say, oh, your education was very important. And then there would be a bar chart. And then under the label education, you could see that the bar was quite large. So it kind of summarized the text, but it's more support than actually being informative itself.
Well, you've mentioned you had some feedback from users. You've got something I consider to be worth more than gold, actual user response data for your project. Could you talk a little bit about the study you conducted?
Yeah, so for this healthy friction study, what we did was we basically created an environment where users could look at job listings and explanations. We had two different types of explanations. One type that was generated by an actually explainable recommender system, and the other one were just nonsense. They were just randomly generated explanations where all of the values were just totally random. And what we then did was invite different individuals of the different stakeholder types. So we invited 10 job seekers, 10 recruiters, and 10 HR people, company representatives is what we called them, to actually engage with that system. We basically just said, hey, here is the system. Try to figure it out with as little support as possible, because it should be like a real world example. Then at the end, we asked them to pick a job based on the explanation, like which one do you think is the best fit? And then also asked them for a couple of subjective evaluations, like how trustworthy do you think the recommendations were? How useful were they? Stuff like that. So that was the approach we used.
Well, thinking about it from the job seeker's perspective, I'm going to look at the job and the explanation. Am I looking at it from my own point of view, or are you giving me like a candidate resume and I'm role-playing a bit?
So in this case, we did some role playing. We had all of the users read either a resume or a job listing, and then told them to pretend to be the company or the individual with that represented, and then look for a job or a candidate on their behalf.
Well, a random explanation, I presume, would be a good baseline, and I should measure that the explainable version should be somewhat better. How do you go about measuring it?
Yeah, so what we did, we had objective variables and subjective variables. So the objective variables was basically based on the random and the real explanations. Do people end up making the correct decision? Do they choose the best fitting job, basically? Because it was a list of 5 jobs or candidates that they had to pick from. And then also objectively, we determined how long does it take them? How many minutes, how many seconds do they take before they end up reaching a decision? And then the subjective metrics were what I mentioned. So it was basically like, how trustworthy do you feel the system is? How useful do you feel the explanations and the system in general was? And how, we called it the transparency, like how well do you understand what the model was actually doing? Like how understandable basically were the explanations?
Well, you'd mentioned there's a correct candidate. In my personal experience, I've been in a lot of cases where maybe there are two candidates that are very strong and it's almost a coin toss. How do you ensure that there's exactly one correct answer in a non-arithmetic problem?
That is definitely true. There's obviously never a fully correct answer when it comes to recruitment. That's also in job recommender systems. It can be pretty fuzzy because at the end of the day, most of it is based on data made by actual recruiters. But yeah, recruiters are humans, so they can't know everything perfectly or can't know everything exactly right. So in the paper, we used an online data set, but in there were ground truth values based on whether someone, I think there were multiple levels going from whether they applied for the job, they had a job interview, or they actually got accepted to the job, something like that. The option that had the highest level, the highest ground truth value was considered to be the correct answer.
And did the subjects in your study sort of faithfully reproduce that, or there's some level of accuracy in picking the correct one?
Oh, no, definitely not. In the study, we actually saw that people made incorrect decisions. They usually picked the second best option. So that was one, I think the scores went from 0 to 3, being like no match whatsoever, up to a perfect match. And they picked the one that was the second highest, I think. One that scored a 1 as a ground truth and one that scored a 3. And they often picked the one that scored a 1 as the ground truth value. So the second best option.
Interesting. Well, what differentiators did you see when looking across the subjects that saw the explainable explanations that were generated versus those that saw the randomly generated explanations?
Yeah, so we actually saw fewer differences than we expected. Like in advance, we thought, oh, this will be night and day. Like they'll very obviously be able to tell which is real and which is random. But it turned out people actually didn't notice all that much of a difference. There were some non-statistically significant trends, especially with the subjective variables, that they liked the real explanations a little bit better, but the differences were pretty minor. We actually were really curious, why are people not telling the difference, even though it's very big? Because it was, to me at least as the researcher, it was very obvious which one was the real one and which one was the random one. So when we looked into their behavior, because we screen recorded everything and we interviewed them, asked to talk aloud while working with the system. So what we basically found out was that people were looking at the explanations and then basically using it as a source of information, but not as a reason to come to a certain decision. So they were looking at the explanation and it said like, I don't know, you studied economics. This is a really good fit for you. And they would just read and be like, oh, this person studied economics. I think that would mean they would be a very good fit for this job. So basically, they would use the explanations as an information source, but then still make their own decision. Like regardless of what the system was saying in the explanation, they would use their own experience as a recruiter or a job seeker or a company representative to come to a conclusion. So we actually saw that the difference between the random and the real explanations as a result weren't all that large.
Interesting. So it's almost as though your users didn't treat the explanation as special, that it was just yet another data point.
Yeah, basically, that's exactly right.
Did they express any differences in terms of those other qualities like trustworthiness or usefulness or transparency? I would hope the explainable answers have some edge somewhere here.
Yeah. So like I mentioned, there's a small trend for them to prefer the real explanations, but it's a non-statistically significant trend. That could, of course, be because our sample size was only 30 people. In a user study like this, it's very difficult, of course, to get a very large sample size. But with 30 people, or an N of 30, it's quite difficult to get statistically significant results. So generally, we saw that they slightly preferred the real explanations, but we can't say for certain that that's the case, because it could also, of course, be down to random chance.
Well, I'd love to zoom in on the recommendation process as well. You'd mentioned earlier having a knowledge graph involved. What sort of knowledge is in the knowledge graph?
The common way that we create the knowledge graph is basically to generate a starting graph based on tabular data. So we have the tabular data that is stored by the recruitment agency. So that is everything that they have on a candidate. So it's anything from their previous work experience, the skills that they have, could be their location, everything basically. And then we define an ontology, so a definition for what the knowledge graph should look like, so what different relationships can look like. And then we do inference to get new relationships. For example, if you have worked as a data scientist, then you can infer that that person must also have the skill statistics. Might not always be the case, but as an example, that's something that you could infer. So that's how the knowledge graphs are generated. We take the tabular data and then do inference on it.
And then the recommendation itself, I know you're essentially matching, I guess, pairs really of a candidate and a vacancy. And that's intuitive in a sense, but how do you represent that in the data?
Yeah, so in the data, it's not necessarily an issue because you just have a pair of IDs, so the candidate ID and the vacancy ID, and then their ground truth value. So yeah, 0 to whatever. But for the system itself, it's a bit tricky because you can't really do it both ways at the same time, really. So what we did was we had a knowledge graph going from the candidate to the vacancy and one going from the vacancy to the candidate because graphs are directed. So an edge going one way might not be going the other way as well. And then we basically took both of those graphs at the same time and made a prediction on how good the match was from both sides. And then, yeah, basically joined those two predictions together to make a final prediction. How well do they match both ways?
Could you talk a little bit more about the features you have available?
That really depends on the company. Each company has their own selection of features that they find important. Honestly, I wouldn't be able to say much for what the general rules are. I know what is used in the companies that I work with, but I'm not sure if they would like if I now start telling about all of the data that they store on the users. But it's very broad. It can be anything that can be relevant for a recommendation.
Yeah, maybe we can sweep a lot of that under the rug saying there's activity data. Clicks are clearly relevant. They convey your intent. You'd want at least those tracked. Then you've got a resume as well. Do you chop it up into embeddings or what else goes into the graph?
Yeah, okay. So in the case that I work with mainly, there isn't usually a lot of click data. It's usually all human annotated. So it's actually recruiter decisions. And then the different levels can be, like I mentioned, whether someone had a job interview, actually got accepted, or had a job interview and then got rejected, whatever, stuff like that. But it is human annotated. And yeah, how CVs and vacancies are dealt with depends on the company as well. So sometimes it's just straight up the plain text. They extract the text from the CV. But sometimes it's also a type of embedding, anything from TF-IDF to BERT-based transformer model embedding. And in the knowledge graph, how we did it initially was actually we created a node for the CV itself and stored the embedding value in that node in the graph. But what we found was actually that people kind of sometimes got confused as a result because there might then be something in the CV that isn't necessarily represented in the rest of the graph. So if something isn't stored in the structured data, but is mentioned in the CV, then there will be a mismatch. So actually a paper that I'm working on right now, it's a collaboration with people from the IT University Copenhagen. There we're actually looking into automatically generating knowledge graphs based on CVs and job listings. So there, again, an LLM takes a look at the CV or the job listing, and based on the full text, it generates a list of edges and thus a graph.
I guess skills are heavily involved then. They're sort of in the middle there between a candidate who can have certain skills and a job which requires certain skills. Is that sort of encoded in a taxonomy, or does something about the training process figure it out on its own?
A bit of both. There's multiple taxonomies actually that work with skills, also with job classification, so that there's a nice hierarchical overview of different job types. But you have the European Standard Classification of Occupations dataset, the ESCO dataset. And in there, I think it's near 14,000 different skills that all have a definition and also are linked to different jobs. So for which jobs those skills are important. But it's also definitely something that can be learned. Not all of the skills that are in the company dataset might be in the ESCO dataset. So in those cases, the model would itself learn which skills are relevant for which jobs.
Well, earlier you were sharing details about the textual explanations and also the graphs one. We skipped over that third case of the graph explanation, which I think now you've described enough users can maybe picture it. What was the user experience like there for someone seeing one of the graph explanations?
So what we saw was that it was pretty dependent on the background that the person had. So especially the company representatives were a bit more positive about the graph-based explanations, mainly because if you work in HR, the odds are pretty high that you've worked with different visualizations in the past. So especially people with a bit more, maybe not statistical, but general data visualization experience, they were able to get the hang of it pretty quickly. Whereas the people who were the recruiters, who were very much focused on the human aspect of things, they often looked at it and were pretty overwhelmed. After explaining it to them a bit, they would usually say like, oh, yeah, okay, I think I could see the use of that, but I'll just stick to the textual explanations. The graph-based explanations can be pretty divisive, but the people who did actually understand them pretty quickly, they did also say that they liked them quite a lot because it does provide a lot of information at a glance, because instead of having to read a full text, you can just follow the thick lines, like the important paths through the graph, and have a pretty good understanding of what is going on inside the model.
Well, how has the feedback from your participants shaped your future work?
Yeah, one thing that was very much based on what we found in previous work was one thing that I mentioned, where there was a bit of a mismatch between what was written in the source text, so the CVs and the job listings, and the explanation text and the graphs themselves. So that is something that we're aiming to tackle right now, that there's more of an alignment between the two. That was the first thing that we learned from our previous research that we implemented in future research. And the other one is basically that lay users very strongly prefer textual explanations. So the job seekers and the recruiters had a pretty strong preference for textual explanations. So what we actually wanted to figure out is then also, how do you generate a good textual explanation? Because one person, in our first paper, actually, we interviewed people as well. And there, one recruiter specifically said, oh, no, I like it when there's a lot of text in the explanation, because then if I call someone up, I have a lot of things to talk about and we can have a nice conversation about everything. And the second recruiter actually said, nah, like 3 sentences, maybe 3 paragraphs in total, something like that is more than enough. I'll figure out the rest myself. So we wanted to figure out what creates that difference, basically, like what personality traits make a person prefer one type of text over another. So in a recent paper as well, what we looked into was basically comparing personality traits to textual explanation preferences. So we had different design dimensions for the explanation. So their length, whether they were running text or bulleted lists, whether they were very detailed, so actually saying this contributed 67% or whatever, or just this contributed a lot, whether it was formal or informal, and then also having it be persuasive or decision support oriented. And then basically did like small personality tests with users, and then figured out how do personalities affect explanation preferences.
Do you have a vision for how your work, as it gets, the wisdom comes from it and job boards learn and they implement some of the techniques you propose or ideas you've had? Do you have a vision for what we're evolving towards? What's the real goal here?
Yeah, so it's basically the hope. AI in general, it won't be used to replace recruiters, but it will be used specifically to support recruiters in their task of matching job seekers and jobs, and then also making the job hunt for job seekers a little bit less of a grueling task, because going through hundreds of jobs can be very tiresome. But it's also a very big decision. It's there's a lot of sunk cost involved if you make a wrong choice when it comes to applying to a job. I mean, as long as you actually hear back, but if you go through the full interviewing process and then figure out, oh, actually this job wasn't really for me, that's obviously a big issue. So we want to find a nice balance where job seekers can quickly go through a lot of jobs and have a pretty good understanding of why it would be a good match, so that they can still personally think like, oh, okay, I think these arguments are important to me, so I think this might be worth pursuing, or I should focus my resources elsewhere.
So there's a lot of different job portals out there, and they vary by country and by region, and we could probably name a dozen between us. They all have some sort of common core there, that essentially you do some sort of search, usually a location-based search, maybe some filters or features, and then you get a list of jobs that are in some ideal order for us. Do you think that format is optimal, or do we need something a little revolutionary here?
I mean, one issue there, indeed, if you just type in a keyword, I don't know, you type in software engineer or whatever, you get the most bland list imaginable. You just get everything that matches software engineer, and then probably indeed in your area. And you can like fine tune it a little bit, maybe on like the salary range that you're looking for in the education level. But what I consider to be a lot more optimal, albeit more difficult and of course compute intensive, is to actually be able to upload your resume and have personalized recommendations based on your full resume, so that it also, for example, in your resume, when you have a little personal section where you talk about what type of, if you're a team player, stuff like that, that's also taken into consideration, and not just your very hard qualifications, basically.
What's next for you?
Yeah, so I'm currently in the fourth year of my PhD, so I should be looking to wrap things up soon. So the research I mentioned about automated knowledge graph construction is still a work in progress. We now managed to generate the different knowledge graphs using different LLMs and prompting strategies and whatnot, but we still have to evaluate how well they actually work, how high is the quality of the graphs that are being generated. And we also want to look into a bit more fairness. Specifically, we want to look into gender fairness and location fairness. So we're also going to be looking into that for the current study. And then hopefully, if we manage to find a company that we can work with for the final paper, what we want to do is do a real world test, basically. So instead of having a mock-up situation, basically, so a role play situation, we want to be able to use a larger data set of actual job seekers who are actively looking for work. And then, of course, the same goes for companies and recruiters.
Well, exciting opportunities there for sure. Where can listeners follow you online?
I'm not very active on social media at all. They can find me on LinkedIn, sometimes update when I'm at a conference, stuff like that. And of course, on Google Scholar and wherever else you can find publications, there you can also find me.
We'll have links in the show notes for listeners who want to follow up. Roan, thank you so much for taking the time to come on and share your work.
Thank you for having me.